Hi guys, in the previous lecture we have seen the concept of reciprocity theorem, Millman's theorem and substitution theorem, and in today's lecture we will solve some previous year gate problem based on all the network theorems. Okay, so before proceeding further, I told you in the earlier lecture that you should revise all the theorems so that when I will be dealing with previous year problem, then you will not get any difficulty. Okay, in this lecture I am considering that you know about each and every theorem which I have discussed in earlier lecture, so I will move fast in order to solve more number of gate problem based on network theorems. Okay, let us see the first question. It is said that for the circuit shown in figure, the Norton equivalent source current value is dash ampere and the resistance is dash ampere. Means we have to find the Norton equivalent circuit across AB terminal. So I have already explained all the concept behind the Norton and Thevenin theorem. So in order to find the RTH, we have to find the RTH across this and we have to find the Norton current across this. Okay, so first I will find the RTH. So I will redraw this circuit. I have already explained you can replace this much circuit with one voltage source in series with one resistance, and the voltage source value is given by the value across this 3 ohm resistor, that is equal to 6 multiplied by 3 divided by total resistance 3 plus 3, that is equal to 6. Means I can connect 3 volt voltage source and the value of resistance will be 3 parallel with 3, that means 1.5 ohm. So if you guys have seen my previous lecture, then you can easily understand how I am converting this much circuit to this circuit. Okay, now what I will do, I will use source transformation to convert this practical current source into voltage source. So this will be like, see the direction of current is from left to right, means the voltage source polarity will be minus to plus, because current will always flow from minus to plus, and with internal resistance 3 ohm, and the value of this voltage source will be 3 multiplied by 2. V is equal to IR, means 3 multiplied by 2, that is equal to 6 volt. Okay, now this is my final circuit. Now I have to find the RTH and VTH across it. So in order to find the RTH, what I have to do, I have to short circuit the voltage source and open circuit the current source. Here we have only voltage source, means we have to short circuit this voltage terminal and this voltage terminal. So I will get only resistance part, that is equal to RTH is equal to RAB is equal to these 3 and 1.5 are connected in series. This is sorted and this is sorted. So overall RAB is equal to 4.5 ohm. Okay, now find Norton current. So in order to find the Norton current, we have to short circuit this terminal. Okay, and we have to assume that some current IN is flowing. Now apply KVL here in clockwise direction. Here IN current is flowing, so I will move from here. I will get minus 3 first, then the voltage drop across resistance will be like this, means plus 1.5 IN minus 6 plus 3 IN is equal to 0. So 4.5 IN is equal to 9, means Norton current is equal to 2 ampere. Means this whole circuit can be replaced by one Norton current 2 ampere in parallel with resistance of 4.5 ohm, and this is my AB terminal. Okay, in this way you can solve this problem. This is asked in 1997 of 2 marks. Let's solve another problem. Viewed from the terminal A and B, the following circuit shown in the figure can be reduced to an equivalent circuit of single voltage source in series with single resistor. Means we have to find the Thevenin equivalent circuit of the given circuit. Okay, so to find the Thevenin equivalent, first I will find the RTH. How to find the RTH across this terminal? To find the RTH, we should short circuit the voltage source and open circuit the current source. Here only two voltage sources are present, so I will short circuit this voltage source and this voltage source. So let's short circuit this. You will short circuit this, then you will get only 4 ohm resistor here and only 6 ohm resistor here, and both resistors are connected in parallel. So RTH is given by RTH is equal to RAB is equal to 6 parallel with 4, that is equal to 2.4 ohm. Check the option. Only B and C having 2.4 ohm. A and D are wrong. Okay. Now find the Thevenin equivalent. How will you find the Thevenin equivalent? Let us redraw this circuit. We have to find the Thevenin equivalent circuit across this terminal. I will use nodal method. You can use KVL also, no problem, but I will go with the nodal method. Why? Because if I will find the voltage across this, that will give me the Thevenin voltage. So no need to find the current first, then apply KVL. The process will be somehow lengthier than applying nodal. So the voltage across this will be VTH. Now I will apply the nodal across this. Since it is open circuited, means the current flowing across this will be 0, means the current will flow across here and the current will flow across here. And I told you when I was teaching you nodal that if you are applying nodal equation at any node, then take that node at higher potential, okay, and assume that current is leaving from that potential. Means let us take this is I1 and this is I2. Got it? Now apply nodal, you will get I1 plus I2 is equal to 0. Now I1 can be replaced by VTH higher potential minus lower potential, that is 10 by 6 plus VTH minus 5 by this value have 4 ohm resistor is equal to 0. When you will find VTH, then you will get VTH is equal to 7 volt. So overall the circuit is replaced by 7 volt voltage source in series with 2.4 ohm resistance, and this is my AB terminal. Okay, let's take another problem. In this problem, this is AC analysis. So till now I have not teaches you AC circuit. Then also you can solve this circuit if you know the basic of AC circuit. Okay, two AC source feed a common variable resistive load as shown in figure. Under the maximum power transfer condition, the power absorbed by the load RL, we have to find the maximum power across this RL. This RL is variable, means we have to apply the maximum power transfer theorem. Remember one point, maximum power transfer theorem can be applied only when the load is variable. It cannot be applied for constant load. Okay, I have mentioned that point when I was teaching you maximum power transfer theorem. So in order to apply the maximum power transfer theorem, first we have to reduce this circuit in Thevenin equivalent circuit. Okay, so first I will open circuit this load resistance RL, open circuit this RL, and find the VTH across this. Got it? This you can easily get by applying nodal. This is my VTH. Okay, so at node VTH I am applying nodal equation at node VTH, means I am considering that this VTH is at higher potential. Okay, means current will leave from higher potential to lower potential. Means I am assuming that I1 is flowing here and I2 is flowing here. So apply KCL, you will get I1 plus I2 is equal to 0. Okay, now replace I1 in terms of potential. You will get higher potential, that is VTH, minus lower potential, that is equal to 110 angle 0 by impedance, that is equal to 6 plus J8. Similarly, you can replace I2 by VTH minus 90 upon 6 plus J8 is equal to 0. So if you will find the VTH, you will get 2 VTH is equal to 200 angle 0, hence VTH is equal to 100 angle 0. Okay, now find RTH. How will you find RTH? To find the RTH, we have to short circuit the voltage source and open circuit the current source. Here two voltage sources are connected, means I will short circuit this source and I will find the RTH across this point. So if I will short circuit the voltage source, means this is 6 ohm, this is J8, this is short circuited. Okay, again I will get this is 6 ohm, this is 8J, and this is short circuited. Okay, now see, this impedance and this impedance are parallel to each other across AB terminal, means RTH is equal to 6 plus J8 parallel with 6 plus J8. You will get RTH is equal to 3 plus J4. Okay, we have VTH, we have RTH. Now draw the Thevenin equivalent circuit. So we have replaced this much circuit with one VTH whose value is given by 100 angle 0 and one impedance that is known as ZTH and whose value is given by 3 plus J4. Now connect load across this terminal, that is RL, which is variable in nature. Now apply maximum power transfer theorem. This is case 3 problem. If you guys don't know what is case 3 problem, you can refer my lecture number 8 of maximum power transfer theorem. You will know that what is case 3 problem. In case 3 problem, the load resistance is equal to RL is equal to magnitude of impedance, internal impedance, that is equal to under root of 9 square plus 4 square, that is equal to 5 ohm. Okay, now find current. Current is given by I is equal to VTH, that is equal to 100 angle 0 upon total impedance, that is given by 3 plus J4 plus 5, which you will get 11.18 at an angle of minus 26.56. Remember this is the RMS value, means power, maximum power flowing through across RL, that is given by I square into RL, means 11.18 K square into 5, which you will get 625 watt. Okay, means option D is correct. Got it? Now let's move to another problem. This has been asked in GATE 2005 of 2 marks. So in the given figure, the Thevenin equivalent pair, that is voltage VTH and impedance ZTH as seen at the terminal PQ, means we have to find the Thevenin equivalent circuit at PQ terminal. Okay, so in order to find the Thevenin equivalent, first we have to open circuit that terminal, means we will open circuit this terminal. Okay, means there will be no unknown network. Now I have to find the VTH and RTH. First find RTH across it. See, in order to find the RTH, you have to short circuit the voltage source and open circuit the current source. So short circuit this voltage source. Now when you will short circuit this voltage source, then this resistor is of no use, because the voltage across this resistor will be 0 volt. Okay, means RTH is given by this 10 ohm parallel with 10 ohm, that you will get 5 ohm. See, only option A and option C. Now find VTH. How will you find VTH? Connect this 4 volt source here. Since 4 volt is here, means it will divide equally across this 10 ohm resistor and this 10 ohm resistor. Why? Because these two are connected in series and the value of resistance are same, means this 4 volt will divide equally. Or you can find according to the voltage division rule, the voltage across 10 volt is given by this 10 volt is given by VTH, and whose value is given by total voltage multiplied by that impedance at which we are finding the voltage, 10 divided by 20, means overall VTH is equal to 2 volt. So option A is correct. Now let us see this problem. In this problem, you have to find the Thevenin resistance across the AB terminal and the Thevenin voltage across the AB terminal. This has been asked for 4 marks in 2009. First see which case it is. In Thevenin theorem we have seen the three cases. Okay, so this is case 2. At least one dependent source and at least one independent source are present. That means that circuit is considered in the case 2. Now find RTH. We cannot find RTH directly here. Why? Because we don't know the resistance offered by this voltage source. So we will find RTH indirectly. First we will find the VTH across this terminal, then I will find the short circuit current across this terminal. Okay, and the ratio of VTH upon ISC will give me RTH. So first find the VTH across this terminal. Okay, so I am reducing this circuit. This much I can reduce with one voltage source and in series with one resistance, which I have already explained you how we are obtaining this. The voltage is given by 5 multiplied by 2 divided by 4, that is equal to 2.5 volt in series with 2 parallel with 2, that is equal to 1 k ohm. Okay, now connect this dependent voltage source whose value is 3 times of VTH. Since I am finding the voltage across, I am considering that the voltage across AB is VTH. Okay, I am finding the VTH, so this is open circuited. This is open circuited. Now my circuit will be like this. This is my 1 k ohm. Now apply KVL here in clockwise direction. Let us suppose some current I is flowing. Okay, minus 2.5, I am moving from here, minus 2.5 plus 1k into I plus 3 time of VTH plus 1k into I is equal to 0. Now see, the voltage drop across this 1k into I is the VTH. Okay, means 1k into I can be replaced by, the current will be I into 1k. 1 I into 1k can be replaced by VTH, means minus 2.5 plus VTH plus 3 VTH plus VTH is equal to 0. So overall you will get 5 VTH is equal to 2.5, hence VTH is equal to 1 by 2, that is equal to 0.5 volt, means option D is correct. Now find ISC across this terminal. We have, this is 2.5 volt in series with 1k, considering this voltage source having 3 VTH. This is 1k and this AB terminal is now short circuited, and I am supposing that Norton current IN is flowing. Since this is short circuited, means this VTH is equal to 0. The voltage drop across this will be 0, means this dependent source will have value 0. Got it? So this dependent source can be replaced by short circuit because VTH is 0, means the voltage across this dependent source will be 0. Okay. Also this 1k ohm resistor is of no use because it is short circuited. So no current will flow here. So this is also removed. Now find the Norton current. Norton current is given by 2.5 by 1k, that is equal to 2.5 milliampere. Hence RTH is equal to VTH upon IN. VTH is, we have already calculated, 0.5 by IN is equal to 2.5 into 1000, that is equal to 1 by 5 k ohm, that is equal to 0.2 k ohm. So option B is correct. Now see this question. The impedance looking into node 1 and 2 in the given circuit is, means we have to find the Thevenin impedance across 1 and 2. See this circuit. This circuit contains only one dependent source, means this is dead circuit. And how to find the equivalent impedance in the dead circuit? We have to apply some voltage across 1 and 2, and we have to assume some current I is flowing, and the ratio of V upon I will give the impedance across 1 and 2. So I am redrawing this circuit. Let us see how. So this circuit and this circuit are same. Now what I am doing, I am applying some voltage here, okay, V, and I am assuming some current is flowing I. The ratio of V upon I will give the impedance. Now apply nodal here at this node V. This is at V potential, means this is also at V. Okay, apply nodal, you will get V by 10k plus V by 100k. This current is entering into the node, means 99 IB. Okay, and this is also entering at that node, means I is equal to 0. Now we can write IB is equal to minus V upon 10k. How? See, this is at V, same potential. So this is at V, means this IB current is flowing from lower potential to higher potential, means it will be in negative. That is given by V upon 10k. Okay, so replace 1 upon 10k plus 1 upon 100k. Replace this IB by minus V upon 10k. You will get plus 1 upon 99. This is 99 upon 10k is equal to I. Okay, finally you will get V upon I is equal to 100k divided by 10 plus 1 plus 990, that is equal to 100k by 1001, that is approximately equal to 100 ohm. Got it? So answer is B. Now let us see this problem. This is most important problem of this lecture. Okay, let us understand it. Assuming that the voltage source are in phase, the value of R for which maximum power is transferred from circuit A to circuit B. We have to find the value of this R. For that, the maximum power transferred from circuit A to circuit B. Now let us draw this circuit. This is 10 volt in series with 2 ohm resistor, then and again series with R. Capacitor can be open circuited. Why? Because it is connected with parallel with voltage source. This is 3 volt. Now see, this whole circuit, means this is circuit B. Okay, we have to find the maximum power transferred from circuit A to circuit B, means this whole circuit is acting like a load. Only R is not acting like a load. If only R is acting like a load, then no problem, the value of R will be directly is equal to 2 ohm. But here whole circuit B is acting like a load, so we cannot find R directly. We have to go with the normal approach. So I am considering here that the voltage V is at this point. Okay, now find current I, and I am considering that current I is flowing from circuit A to circuit B. Now apply KVL here. Okay, if you will apply KVL, then you will get I is equal to 7 by total resistance is equal to 2 plus R. Now find voltage. V is equal to 10 minus 2I, that is equal to 10 minus 14 by 2 plus R. 10R plus 6 by R plus 2. Okay, now power transferred from circuit A to B is equal to voltage across this circuit B terminal multiplied by current entering into this terminal, that is equal to VI. So V can be replaced by 10R plus 6 by R plus 2 multiplied by I can replace by 7 upon 2 plus R. Now differentiate this power with respect to R and equate it to 0. Then only you would be able to find the value of R for which maximum power transferred from circuit A to circuit B. Okay. Now P is equal to, we have 70R plus 42 upon R plus 2 whole square. Now differentiate it with respect to R. You will get R plus 2 का whole square into 70 minus 70R plus 42 into 2 into R plus 2. Equate it to 0, you will get same like this. This R plus 2 cancel out each other, means you will get 70R plus 140 is equal to 70R plus 42 into 2, means finally you will get 70R is equal to 140 minus 84, hence R is equal to 0.8 ohm, means this is the answer. Most of the guys will do mistake in this and they tick on the R is equal to 2 ohm because they think that only R is variable, but here the load is whole circuit B, not only R. So we have to consider R in series with 3 volt as a load, not only R. If the question is like that, find the maximum power transfer across the R load, then you can easily say that R is equal to 2 ohm. But the question is saying find the maximum power transferred from circuit A to circuit B. Okay, so R is equal to 0.8 ohm is the answer. Now let's see the another question. A source voltage VST is equal to V cos 100 pi t has an internal impedance of 4 plus J3. If a purely resistive load is connected to this source has to extract the maximum power out of the source, its value is, we have one source impedance, source voltage in series with impedance whose value is 4 plus J3, and I am considering the load which is purely resistive in nature. Okay, and I have to find the value of RL for which source will transfer maximum power to RL. This is in MPT, when I was teaching you MPT, this is case 3. Okay, and in case 3 the value of RL is equal to magnitude of constant, and whatever the constant value is, that is magnitude of 4 plus J3, you will get 5 ohm. So option C is correct. See in this circuit, in circuit Vs is given by, then the Thevenin equivalent voltage as seen by the load resistance RL, means we have to find the Thevenin voltage across this terminal. Okay, in order to find the Thevenin voltage we have to replace this RL by open circuit. Okay, now when I will replace this RL by open circuit, then the current I2 will be 0 because it is open circuited. So finally I will get VTH is equal to, if you will apply KVL here, then the voltage drop across this impedance will be 0 because current I2 is 0. So VTH is equal to 10 VL1. Got it? Now find VL1 by using this circuit. Since the current is I2 is 0, okay, I2 is 0 means this dependent source is depending upon the I2. Since current I2 is 0 means this voltage source is 0, means it is short circuited. So draw the equivalent circuit. First find the current. Current is given by Vs upon magnitude of 3 plus J4, that is equal to 3 plus J4, that is equal to 100 angle 53.13 by, this will be 5 at an angle of 53.13. this is 4. Okay, hence you will get I is equal to 20 angle 0. Now the voltage VL is equal to I into reactance, that is equal to I into J4 multiplied by 4 at an angle of 90, means 80 at an angle of 90, means VTH is equal to 10 VL1, that is equal to 800 at an angle of 90. So option C. See this circuit, we have to find the Norton equivalent from XY terminal. Okay, so first find the RTH. Okay, for finding the RTH we have to short circuit the voltage source and open circuit the current source. So if I will short circuit this, then I will get 2.5 ohm here, this is short circuited. Now 5 ohm connected with 5 ohm, and this voltage source is also short circuited. Finally I will connect 5 ohm here, and I have to find the RTH across this. So this is 5, this is 5, parallel combination will be 2.5 and 2.5 in series with 2.5, that is 5, again parallel combination with 5, that is equal to 2.5 ohm. Okay, RTH we can find is equal to 2.5 ohm. Now find the Norton current. For finding the Norton current, what I will do, I will change this voltage source, practical voltage source, into current source by using source transformation. Then I will get, this is 1 ampere current source in parallel with 5 ohm, then again in parallel with 5 ohm, this is 2.5 ohm, and this is I am having voltage source of 2.5 volt, and we have to find the Norton current across here, means I will short circuit this terminal, means this resistance is of no use. Okay, because the voltage drop across it will be 0. Now take the parallel combination of this 5 and 5, you will get equivalent is equal to 2.5. Now again redraw this current source into voltage source, you will get 2.5, this is 2.5, and this is also 2.5, this is sorted. Now if you will transform this practical current source into voltage source, you will get 2.5 in series with voltage source having value 1 multiplied by 2.5, that is equal to 2.5. Now find IN, you will get IN is equal to 0, because this 2.5 and this 2.5 will oppose, and finally the Norton current will be 0. So we can make the Norton circuit like IN is equal to 0 ampere in parallel with RTH is equal to 2.5, and this is my XY terminal. Okay, now see this problem, this has been asked in GATE 2015, and we have to find the Thevenin equivalent across AB terminal. Okay, this is case 2 problem. In case 2, first we find VTH, then we find ISC, and the value of RTH is given by VTH upon ISC. We cannot find RTH directly because we don't know the resistance offered by this dependent source. Okay, so first find VTH. Let us draw this circuit. This is 2 volt having 1 ohm. Since this is open circuited, means we are finding only one node. Let us assume this V. Okay, at node V, when you apply nodal at V, you will get V minus 2 by 1 plus V by 1 plus V plus 20I by 2 is equal to 0, and according to this I can be given by V by 1, that is equal to V, I is equal to V. So we can replace I with v. So I will get 2v plus 21v by 2 is equal to 2. Okay, 25v by 2 is equal to 2. v is equal to 4 by 25. Now apply KVL in this loop, assuming that VTH is the voltage drop across this 2 ohm resistance. So you will get minus I minus 20I plus VTH is equal to 0. Hence VTH is equal to 21I and I is equal to V. You know this, I is equal to V means 21 into 4 by 25, that is equal to 84 by 25 volt. So we have solved all the numerical based on network theorems which has been asked in GATE. Okay, now here we can conclude, after solving this much of problem, we can conclude that if you know the nodal, Thevenin and maximum power transfer theorem, then you can easily solve the previous year GATE question. In today's lecture we solved maximum of the problem based on Thevenin, nodal, Norton and maximum power transfer theorem. So if I will put in the priority list, means Thevenin is most important, okay, then MPT theorem, then reciprocity is asked in a state government exam, then superposition, then Millman's, then substitution. Okay, that's all about this lecture. In the next tutorial we will see a steady state response by using Laplace transform. If you guys understand the concept, then please like this video and share this video to your juniors. For new updates you can subscribe this channel, and also for doubt solving join our Facebook group. Thanks for watching this video.